Hi, good afternoon, everyone. I appreciate it's the last talk before a little break, so I'll try not to go over. Hope everyone's enjoying the conference. And today I want to talk about my favorite subject, which I'm sorry is not Erlang or Elixir. It is, in fact, Gleam. But first, I'm Isaac. I'm the CTO at a company called Rover. We turn code like this into graphs of functions like this and look for bad patterns like n+1 database calls and stuff like that to try and make sure you don't push bugs into production. But as painful it is to admit, I'm also a YouTuber. And that's kind of where our story starts today. This is a little bit of the self-indulgent portion of the talk, so I'll try to keep it quite short, but I think it's kind of important to have context. You see, I didn't come into Gleam deliberately. I didn't sit down and spend hours researching the perfect language for 2025 or all these other things you see out on the internet. As I mentioned, I'm a YouTuber. Originally, I started making videos about Python, mostly because it's the language I was working with at the time. And fed up with slow, beginner-aimed tutorials, I started a series called Impatient Devs, where I tried to teach a language to existing developers, sort of mid to senior level, as quickly as possible so they could get up to speed in a new job. But then suddenly I started seeing loads of YouTube coverage for this little language I'd never heard about before. And there was a lot of hype around the V1 release of this language called Gleam, which was created by some little British guy somewhere. But it seemed like it was taking the internet by storm. So, like the good little clout-chasing YouTuber I am, I jumped on the bandwagon. And then I made another video, and another one. And it turned out that while making that first Impatient Devs video about Gleam, I'd kind of fallen in love with the language, and especially the community around it. And inadvertently, I'd become the Gleam YouTuber, or if you want to use the official term, I believe it's the Glambassador. So as you can see by my shirt, I decided to stick with Gleam, and today I'd like to talk about a few of the reasons why, and the things that ultimately convinced me to, well, make it my entire personality, but also to put it into production at Rover, my company. So firstly, Gleam is a very, very simple language. People can sometimes be scared off by static type systems, but Gleam's philosophy is one way to do things, and that makes it incredibly easy to pick up the language in probably an afternoon. And I'm kind of serious about that. It's the only language I learned for this Impatient Dev series that I actually remembered how to write after publishing the video. I'd done HTMX and Zig and all of these things, and just in one ear, out the other afterwards. It's got a very familiar syntax for folks coming from C-like languages, which are my background, and they are the most popular languages these days, as much as it pains me to admit. The compiler is smart enough to infer the static types most of the time, so if you are one of those people who get scared by them, you can just let it do its magic and kind of pretend they don't exist. This is all valid Gleam code. It's all statically typed, not a single type annotation in sight. The language only has 22 reserved keywords, all on the screen right now, and only 14 of them are actually currently in use. The other 8 are reserved for potential future features. You can kind of see what they might be. I don't think some of them will be implemented, but that's what it is. But there's not a lot to learn, is the point. But this isn't really just good for people who want to learn Gleam. It makes Gleam adoption very easy, either for your project or your company. And your whole team could be productive using Gleam within the week. You know, even that team member. You know the one I'm sort of talking about. But don't be fooled. Just because Gleam is quite new and quite simple, it doesn't mean it can't be powerful and very expressive. Let me give you a bit of an example. Of the aforementioned 22 keywords, my favorite is the use keyword, and that's because it's very useful. Sorry. But with it, you can implement all sorts of features that in other languages, you normally need special keywords or syntax. So, kind of from the talk earlier, you can implement something like Go's defer or Python's context managers if you want to emit telemetry or run cleanup code once you're done with a resource. You can emulate early returns in a language that doesn't have them, and it keeps control flow simple without nesting forever. And it can even nicely chain middleware in a web server. So it's really easy to see the path that a request is going to take and sort of follow it through. So what does this all-powerful use keyword do? It just flattens out a callback. So it takes something like this and turns it into something like this. But that's all it does. but it means you get all these great features for free, just writing functions as you would in any functional language, but you don't get that rightward-leaning pyramid of doom that often appears in callback-based code. And the language server can do these transformations for you in a code action. So you don't need to necessarily worry about understanding it all day one. But it's simple, well-designed things like this that make Gleam code really elegant, without loads of hidden control flow or days of reading preprocessor documentation or things like that. And you can just sort of grok it very easily. So how do you actually get started? Well, Gleam doesn't have its own runtime. It's most often compiled to Erlang to run on the Beam, and that's the only reason I was allowed in the front door today. But it also compiles to JavaScript. And this kind of, plus the ability to use what we call FFI, or foreign function interfaces, to call out to these language, makes it really easy to just adopt Gleam into existing code bases incrementally. This @external annotation, you put that on a function declaration, choose the language you want to target, and reference the module and function you want to call. The only thing you really have to do is make sure your types are right. As smart as the compiler is, it can't type check across that language boundary, especially given you're trying to type check against dynamically typed languages. And because of this JavaScript interop, and this is quite an important thing, people can come into and get a lot of use out of Gleam without actually needing to learn anything about the Beam. And while the Beam is really powerful, obviously we're all here, and we should definitely be encouraging people to learn it, it's also very different from a lot of the other virtual machines out there. And for someone new, it can be a bit daunting at first glance. According to the recent Gleam developer survey, most people who come into the language come from web backgrounds like TypeScript, but also other C-like languages like Python, Go, and Rust. And I couldn't fit every language that other Gleamlins, and yes, that is the official term, use on this slide. So to break it down a little bit, the number of people who come to Gleam from Elixir and Erlang is about 7% of the total Gleam population. But the numbers show that 2/3 of Gleam applications run on the Beam. Or to put it another way, rather than replacing developers in ecosystems like Elixir, Erlang, LFE, Gleam is growing the Beam community as a whole. And like I said, I personally think that's very important and quite fabulous, because the Beam is this incredible piece of technology that deserves to be celebrated. But what if you're trying to introduce Gleam into existing projects? You know, you're not adopting it incrementally. You want to write something from scratch. Gleam's pretty new. Does it have everything you're going to need to get the job done? Well, actually, yes. Like I said, Gleam programs can take advantage of two incredibly mature and combat-hardened runtimes, the Beam and one of the various JavaScript engines. And Gleam kind of does take full advantage of that. For the backend folks, there is a robust, type-safe implementation of a lot of the functionality from OTP that lets us tap into the Beam's famous concurrency model and fault tolerance. And a lot of ecosystem libraries are built to use this from the get-go, obviously, like Wisp, which is a framework for high-traffic API servers. We have Lifeguard, which is a pool boy-inspired worker pool for managing all your actors. Barnacle is a Gleam implementation of the fantastic Elixir lib cluster for creating clusters that just don't die. And finally, we have BG Jobs for, well, background jobs. We're really inventive as a group. But of course, we also have clients and query generators for pretty much all the major databases, including the ones I couldn't be bothered to find logos for. In particular, the Mongo and Redis/Valkey/whatever clients for Gleam all use Lifeguard to implement connection pooling. Our Postgres client is built on Pigo, so again, has built-in connection pooling. So that kind of takes that load off your shoulders when you're building applications. But because we can compile to JavaScript, if you're more front-end aligned, we have a framework called Lustre. Fans of Elm in the room? This uses the Elm architecture of that sort of model view update loop and allows you to run it on your front end in JavaScript, but it also bridges the gap back to the server. So you can have server-side rendering and Phoenix Live View style real-time server components running on the Beam. If you want to know more about Lustre, I'd highly recommend this talk. It's from Lambda Days last year by Haley, who's the creator of Lustre, and it kind of shows how these Lustre components can run anywhere you want to put them. And because it's all one language from front end to back, you get the benefits that all the JavaScript and TypeScript folks tout of being able to share code between the client and the server without actually having to run JavaScript on your server. So this is why we put Gleam in production at Rover, but what's it actually been like for us deploying Gleam and relying on it to satisfy our customer base? Well, I mean, I wouldn't be here if it hadn't been pretty great. And even I, as the Gleam evangelist I am, kind of underestimated how easily Gleam would just slot into our tech stack, and we're a mostly TypeScript shop. But all these things I've been talking about so far, they made it really easy. As did, of course, things I haven't mentioned, like the very fast comprehensive build tooling that has your builder, your tester, and everything like that in one binary. We've started using Gleam internally to orchestrate all the background jobs that happen in our system. Gleam's type system and exhaustiveness checks on pattern matching, along with classic BEAM goodness like supervision trees, have given us pretty much total confidence that all our code will handle pretty much anything we throw at it. It's been chugging along happily since we deployed it, not a single incident so far, fingers crossed. And we've mostly been able to lean on the Gleam ecosystem, but because of FFI, we know that if we need to, we can dip into Elixir or Erlang. And then, of course, there's the team. There's only a few of us at Rover, but all the others picked up the language in literally a matter of hours. And now they're all Beam converts too. I forced them all to watch the Sasha Urich talk, and now that was kind of it. And in fact, they love Gleam so much, they've been pushing to rewrite our internal admin dashboard to use Lustre and server components. So instead of just having a point-in-time view into our system, we can have a real-time view into our system. And we even added Gleam support to the product, enabling us to create graphs of all the function calls in a Gleam codebase. And this is what the Gleam standard library looks like. But Gleam simplicity meant I could do this in 2 days, rather than the multiple weeks and admittedly many bugs in my code that were involved in doing this for other programming languages. I mean, who knew JavaScript had so many ways to call a function? But anyway, I'm just some dude who spends an unreasonable amount of time in front of a camera at home, so why do you have to listen to me? Well, I mean, for starters, this is a one-track conference, and the other option would be socializing, so... but if that doesn't make you want to take my word as gospel, I've gathered a couple of case studies from other folks who are using Gleam in production like us. People like Mark Holmes of Williams & Holmes, and they use Gleam to make sure that distributors can get their food and drinks from their warehouses to their suppliers and ultimately onto your plates. And Mark said this: "What's so great about Gleam isn't how fast and simple it is to build things, although that is true, but it's how easy it is to come back later and refactor. Maintaining Gleam applications is a really great experience. Like I said earlier, we have exhaustiveness checking when we're doing pattern matching, so if you add a new pattern, the compiler will tell you where you've missed it. Hands up if maintaining old code is the most fun part of your job." Yeah. Well, with Gleam, it might be. Or you could listen to the creator of Nestful, which is a different thing. It's a local-first productivity app that uses CRDTs to resolve the state of all your to-do lists, even if you've made loads of offline changes across multiple devices. And they said that Gleam's type safety and ergonomics allow so much heavy lifting that they make the solo developer look like a small army. And the person who created Nestful is a solo developer. It's a pretty cool project and entirely almost written in Lustre. There's loads of good detail on their technical blog, which I can definitely recommend a read, and it's linked here if you're quick. There's also Steerlab, which is an AI platform for winning software contracts. And their product is almost entirely Gleam microservices around RabbitMQ. And their VP of engineering, Guillaume, has contributed a lot to Gleam, especially Lustre packages. And they told me that Gleam is the best choice they've made for their team. They've got type safety across the stack, and it's drastically cut down the number of bugs they experience. And kind of my favorite, and certainly not least, although he is last, Peter Saxton, one of Gleam's oldest production users. He originally wrote the Gleam backend to compile to JavaScript. But he's currently trying to redefine how we think about software reliability with his own programming language, EYG, which is all written in Gleam, and the website and editor are all in Lustre. And Peter had this to say: since we really understood the benefits of Gleam, we haven't written a single test. Fearless refactoring is real. Now, they use it in production at their company, and I think they actually do write tests. I think he might have been over-exaggerating. But they go a lot longer before they find it necessary to do that. So hopefully by now I've not bored you too much and convinced you to give Gleam a bit of a go. So how do you go about it? First, get comfortable with the language. It won't take long. You can use the Gleam tour. It'll take you through all the syntax and a lot of the features you need to know to get a feel for the language and how it operates. It all runs in the browser, no server security problems. It's a WASM build of the compiler, and it uses JavaScript target to just run things. And if you want to go a little bit deeper, this is one of my personal contributions to Gleam, which is the playground, which will give you the compiled JavaScript and Erlang output as well. So if you are working with Gleam and you want to see how is this going to be represented in Erlang so I can do a call across that language boundary, this is really helpful for that. And then, like I said, that's kind of the next step, that FFI, that working across language boundaries. Start adopting Gleam incrementally. You can use FFI to call out to Erlang or JavaScript code, or you can import your built Gleam modules into those languages too. And from conversations I've had with Gleamlins who've successfully infiltrated their workplace, Gleam's type system is really helpful when you have part of your system that needs to handle every possible edge case. And sometimes the way to do that is crashing, as I'm sure we all know, but sometimes we want to make sure we've got it. And the compiler will scream at you if you've missed something. Another good place to use it is that boundary between your backend and frontend, and being able to reuse types and code across that boundary is quite a nice feeling. And then, slowly, over time, you'll do what I did, become Gleam-pilled and utterly unbearable to your coworkers, because you'll mention it at every possible opportunity, until they become Gleamlins too. Thank you.
Yes, thank you, Mr.